Welcome back. In this video, we are going to solve problem 10.13 that is taken from chapter number 10, column. So statement is a column of effective length L can be made by gluing together identical planks in either of the arrangement shown. Determine the ratio of critical load using arrangement A to the critical load using arrangement B. So you can see this is arrangement A and this is arrangement B that is made from three planks, identical planks in this arrangement and using this arrangement. So you have to determine the ratio of critical load using arrangement A and arrangement B. So let's start with the solution. So for arrangement A, I will first find for arrangement A, we know that critical load for arrangement A, our general formula for critical load can be written as pi square EI divided by effective length square. Clear? Now we will find this I for the first case, which is A. So you can see this distance is D divided by 3. This is also D divided by 3. And this will also D divided by 3. And their sum will also give you this distance D. And you can see that this shape is rectangular. So moment of inertia IA will be equal to Ix since it is rectangular. So I double X is equal to I double Y, and that is equal to 1 over 12 base into height cube. So base is, you can see D, and height is also D. So 1 over 12 D multiplied by D cube. So what we will get, IA will be equal to 1 over 12 D power 4. So if you take this is its horizontal axis, x-axis, and this is its vertical axis, y-axis. So I double x is equal to I double y, which is the moment of inertia of this section. Now the effective length will be L. So if you put it in this formula, so what we will get is that P critical for arrangement A will be equal to pi square multiplied by E, and moment of inertia will be 1 over 12 D power 4 divided by LE square. So if you simplify it, so you will get P critical for arrangement A will be equal to pi square E multiplied by D power 4 divided by 12 LE square. This is your equation number 1. This is the critical load for arrangement A. Now for arrangement B, we know that critical load for arrangement B will be the same formula, pi square E multiplied by I divided by LE square. So what we will do is that here we will take I minimum. Why? Because let me show you, if you take the half of this horizontal axis, so this will be x-axis, and if you take this vertical axis, so it will be y-axis. So here you can see you have I double x, moment of inertia about x-axis, and moment of inertia about y-axis. Since this height is larger, clear, as compared to the height about y-axis, so I double y will be minimum. So I can write it I minimum is equal to IYY, and we know that in critical load we use the minimum moment of inertia about the axis. Clear? So here what we will do, I will find IYY. So for that you can see first these two elements, and it's having this height is D, because the height of this plank is D, and this width is D divided by 3. So let me write it from this till this. This is D, and from this to this thickness is D divided by 3. So about y-axis, this will be its breadth D by 3, and height will be D. So I can write it as 1 over 12 into D divided by 3 multiplied by height, which is D cube. Now the second element is this one. So I can say that about this y-axis, this height is D, and this D divided by 3 is height. This is width. Clear? So I can write it plus 1 over 12, this base D, this one, from this till this. This is D. Clear? And D divided by 3 is its height. So D divided by 3 whole cube. Plus the last one, which is this one. So again you can see about this y-axis, this height is D and this is its breadth, which is D divided by 3. So plus 1 over 12 D divided by 3 into D cube. Okay. Now if you simplify it, so you will get I minimum will be equal to Iy, and that will be equal to 19 divided by 324 D power 4. Now you have this I, just plug it in this formula. So what we will get is P critical for arrangement B will be equal to pi square E multiply by 19 divided by 324 into D power 4 divided by LE square. So from here you will get it 19 pi square E into D power 4 divided by 324 LE square. So this is your equation 2. Now it has been asked to find the critical ratio of arrangement A to the critical ratio of arrangement B. So what we will do is that divide equation 1 by equation 2. So what we will get is that P critical for arrangement A divided by P critical for arrangement B will be equal to this is the A, so pi square E into D power 4 divided by 12 L E square divided by 19 pi square E D power 4 divided by 324 LE square. Okay, so what I will do is that pi square E D power 4 divided by 12 LE square, and when you convert this division into multiplication sign, so this new denominator will goes upward, so 324 LE square over 19 pi square E D power 4. So this pi square will cut with this, E will cut with this, D power 4 will cut with this, and L square will cut with this. So we will left with 324 by 19 multiplied by 12. Okay, so this will give us P critical for arrangement A to the P critical for arrangement B. Now what we will do is that you can see 324 divide by 19 multiply by 12 will give you 1.421. So that is equal to 1.421. And what we will get is that P critical for arrangement A to the ratio of P critical for arrangement B is equal to 1.421, which is the answer of our this question. And that was all about this problem 10.13. I hope you have enjoyed this video and you have learned from this. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.